Okay, so here is my final project. So before I go ahead and walk through the code, I'll just open it up and just kind of show what's going on with the scene here. So the setting for the final project, we have just kind of a pretty simple, just kind of boxed in room here. So if we zoom out a little bit, it's just a very simple room. We have a couple different chairs and a table. We have a couple different objects on here. The most notable, we have a checkerboard with the checkers there. We also have a couple other game-related objects as well. We have a couple dice sitting over here, a couple pool balls sitting over here. So kind of walking through what each of these objects are, we're utilizing both some objects that are strictly set to one color. The chairs and the table, for example, and the checkers as well are some of those objects that are just restricted to one color. And then other objects such as our checkerboard, the pool balls, the dice, and the walls as well are built around the textures. And then we do also have a couple different lights in here, our directional and our point light. And then the spotlight is the one that is moving around the room and then, when you see that it's moving from one side of the room to the other, the objects like the chair and the checkers do respond to the light moving around. So now I'll just kind of walk through both our initializer function and then our draw function. Just kind of walk through the code here and do my best to explain what's going on. So we can ignore the shader texture and the shader color. I'm not really using these right now. We want to focus on our texture light shader and our color light shader. So these are the shaders that we need to activate. We activate these within the draw scene depending on which objects that we want to render. So, when we declare what these are, we are setting we are setting the shader here, and each one is using its own HLSL file to be run on the GPU. So, in the case of our texture shader, we're using the texture light HLSL, and then our color light shader is using our color light HLSL right here. And then before I'll go into the HLSL files here. So the information that is passed in here, we're basically looking at both our lighting information, and then we also have the vertex shader and the pixel shader are on here to process, the vertex, how to process the vertices, and then how to color the pixels. So, a lot of this is related to the lighting. So we're passing in the material properties for how we're going to affect the surfaces of our objects. We have the light properties, the Phong model. So we're using, the ambient, diffuse, and specular. And then we do have some structures for the three different kind of lights, our directional light, point light, spotlight. And then we also have some other constant buffers that are updated on the CPU. So we have our camera data to send in the view projection matrices. Then we have our light parameters for the different kinds of lights. And then we have our instance data for the specific object. So we get its world matrix and as well as its model space. And then its material information, which could be related, like in the instance of color, for instance, we would be sending its color information to the light, so that color is reflected onto the object itself. Then we do also have the functions for computing our directional, point light, and spotlight as well. Then we have our vertex shader, our pixel shader, and then we just calculate the ambient, diffuse, and specular right here. And then, just in the case of the color light, if I scroll to the bottom of this one, we calculate the lit color based on the results of these and return that lit color. Texture light is very similar. We calculate the lit color and multiply it by the specific color of the texture that we're currently looking at for that specific pixel. So those are the shaders that we have built in. And then we also have the input layout. So for our shader color, we are only concerned with the position and the normals from the model. So these have to match up with our standard vertex. So just taking a look here, we do have our position, our UV mapping for the textures, then our normals, and then optionally the colors. So the position and the normal do match the correct order from the model. And then similarly, our texture light, position, text chord, normal, that also follows the similar order that we had here. So we have our position, text coordinates, and normal there as well. And then, of course, these semantics do also match up with the ones that we have in here as well. So we have our position, normal, and text coordinate, here as well for the shader texture. And then we also set the data for our we set our camera buffer, our light parameters, and the world and material buffer here as well, once we call these. So that's just initializing the shaders here. The lights, so again, we have 3 different kinds of lights that are being used in the scene. The directional and point light have to be rendered for each, are currently being rendered for each shader. So we have the 2 shaders, so we send in the exact same parameters for both of those. Directional and point light are rendered, are just initialized once, and then the same exact data is rendered every single frame. The spotlight is a little different because, if we recall, the spotlight is the one that's moving around the scene. Its position is being updated every frame. So that one is, those properties are being set every single time in the draw scene, but we'll get to that eventually. So, basically when we're doing this, taking a look at one of these, the directional light, for instance, we set its parameters for ambience, diffuse and specular, and we also get the direction for the directional light. And then, point light is very similar. We set those parameters. We also get its position, attenuation, and range. So we set those parameters here. And then we do have a model class. So the models, most of these models are pre-built shapes that I had made myself. And all but 2 of them are actually pulled in from files. So I'll just kind of walk through each of these. I'll just kind of walk through each of these pre-made models, and then I'll briefly look at how the code works for the pre-built models that we pull in from the Azul file. So if we go into here in our model, we can see that there's a bunch of names that are already set here. So depending on which one we choose, depending on which one is declared, it'll call a specific function, and we'll get from that the number of vertices, its vertex array, the index array, so on and so forth. And the functions can vary a little bit here. So I'll just kind of quickly go through each of these as well. So the one that we're using, the one that we want to focus on, we have our 6-face texture for the box. This is the model that's being used specifically for our die, for the dice. So, basically for each shape, for each side of the cube, we render 4 distinct vertices, and then we have 2 triangles for each face as well. So the set function here, we're simply setting its position in the world space. And then we have our UV coordinates, which are mapped to the specific part of the texture. And then we also set our normals for the lighting here as well. And then it follows a very similar pattern for the other faces. And then our create unit pyramid. So I don't actually have one included in the scene, but I'll still walk through it anyway. So again, very similar, we set its position, we set the UV mapping for it. And then the normal mapping for this is a little different compared to what the cube is. So because since the cube, the sides are all flat and relative to the direction of one of the three axes, it's very easy to determine what the normals are. So, you know, when for the forward face, that's directly going in the direction of positive z, so the normal for that would be 0, 0, 1, whereas, you know, the back face is going in the direction of negative z and only negative z, so that would just be 0, 0, negative 1, and it's pretty similar for all the other faces. But the pyramid is a little different because 4 of its 5 faces are going in more than one direction. So basically what I did to calculate these normals, I manually, since this is a fixed shape, I just manually calculated the normals by getting the cross product of the two vectors from that face. I calculated the cross product and then normalized that here. And then again, the bottom, you know, the bottom is very simple since it's going in the direction of negative y, so that normal's very easy. And then the create unit sphere, this one is definitely a little more complicated. Basically, what's going on here is we kind of have a formula for establishing the 3 different sections of the sphere. What's important to note with the sphere is that we are able to modify basically how many polygons it's made out of. So this 12 and 12 value represent the vertical slice and horizontal slice. So depending on those values, it'll just kind of determine like how good the sphere looks. So the sphere is always going to have a top and bottom row, so we just establish what those positions are relative, and then we, you know, basically for each vertex we do some kind of rotation, and then we also establish what the UV mapping would be for that relative to where its location is in the world. Similarly for the lights as well, for the normals as well. And then the middle rows, depending on how many horizontal slices we have, we basically just kind of go down and do a very similar pattern. And then the bottom row, we just finally finish it up, and then we normalize those normals. So one other thing I do want to show, that we can change these, we can change the number of vertical and horizontal slices, so it is dynamic. So again, the pool balls are the ones that are using the sphere model. So if we go back into our program real quick, so you'll see that the models now for the spheres are much more jagged because there's only 3 vertical slices and 2 horizontal slices. So even though the textures still look pretty okay, the models themselves are a lot more jagged, but that's just showing that they are in fact live and we can change those. So let's set that back to 12. And then the flat plane, so the flat plane, I am using versions of the flat plane and the skybox. I did decide to just basically go ahead and incorporate those as their own models, as instances of the model class. So they're all incorporated in there, but they still function the same as they had previously. So, you know, basically flat plane's very simple. We just get its position based on the size, get H rep and V rep depending on how much we want to repeat the texture. So, you know, in this case, I'm using the checkerboard for that as well. So, you know, we repeat the texture a couple different times depending on the values for that. So 4 and 4. And then we have its normal. And then, and then the cylinder is another custom shape that I made specifically for the checkers. So, you know, again, it's very similar to the sphere. It follows a similar pattern depending on where the position is of the vertices. We follow a pattern of getting those all correctly aligned, counterclockwise rotation, getting the normal set there. And then the sides, depending on how many vertices we want around the circumference of the cylinder, we'll determine how we calculate the sides and these as well. And of course, we do also normalize those normals here. So actually, this is another thing I want to showcase here. So I will be able to change the number of vertices we want to show around the circumference. So currently it was set to 16. So the checkers appeared very natural, very round in shape. But, you know, if we change that to something like 4, you know, we can see that those are updated there. So they're a lot more jagged. But again, just like the spheres, we're able to automatically change what they look like just by changing this one value. So let's set that back to 16. And then I did also incorporate, again, just like the flat plane, the skybox is its own model here. It's incorporated as one of these default values for the model. So this was the default one. I'm technically not using this particular one. I don't have a traditional skybox because traditionally the skybox works, it doesn't respond to lighting. So there's no normal coordinates that are sent in. And the UV mapping for a traditional skybox usually would use one texture, but it uses different parts of that texture. I basically made my own version of the skybox to work specifically for the room that I created. So again, if I just quickly pull this up, the room that is surrounding the skybox that I made is just basically the walls and the ceiling of the room. So it's all using the same texture. The difference is, so the difference between a normal skybox and this one, it's responding to the lighting in the room, and it's using the same texture, but just like the flat plane, it's repeating it. But besides that, it's pretty much the same as what the regular skybox is. So, you know, we send in the length parameter, we determine what the length of it is, determine the UV, how much we want to repeat that, and then the normals are very easy to calculate. They're just the inverse of what the cube would be. So those are the models. That's pretty much just a walkthrough of all the models I'm using. And then we'll also quickly take a look at the pre-made models that are on here as well from the Azul file. Just checking the time. Okay, so taking a look at this function, basically what we basically just go ahead and load the vertex and the index data from the Azul file. And then in the case of all these model constructors, once we get our vertex and our index information pulled either from our prefixed models or our models that are loaded from files, then we just go ahead and load the data to the GPU. So those are the models, and then the textures. Again, we have a bunch of different textures that are loaded on the computer that we just pull those files from. We get that information, and then, so going in here, we have those. And then our world matrices, these are just used occasionally for some of the objects when we're actually rendering them on the screen. So you know, like if there's one instance of a graphic object, which we'll get to in a second, if there's one instance of an object that we want to duplicate, like let's say we just want to change its position, you know, we can just have the scale across all of those instances say the same, but still change the position just depending on what we need. So that's set there. And then finally, the last big part of our initializer stage are the graphic objects. So we have versions for both texture light and color light. And these are set if we actually pop into one of these here. So our graphic object for the texture light is built to accompany, you know, the shader, the texture light shader that's passed in, the model that we want, then the texture that we're looking for, and then the world matrix. So alternatively, we can either set the, you know, we can set the shader. We always set the shader and the model right here in the initializer. But, you know, if we're making several instances of this one graphics object, we can, in the draw scene, we can call these other functions such as the set texture or set world. So if we wanted to make another version of the object with a different texture or change its location, we can just do that in the draw scene and then just render the object again without having to make a completely different new graphics object. And then, you know, the color light graphics object is very similar, except the only difference is instead of a texture, we just have the color. And then for the color, we'll get to the render function in a second here. So yeah, that's basically what the graphic objects boil down to. So again, they manage, the whole point of the graphics objects is to take the shader, the model, the world position, and then the color or the texture, manage it all into one object. So once we get down into our draw scene, it's very easy to go ahead and see. We just simply call the render on that graphic object. And then behind the scenes, it performs its various functions to get it into the world and have it show up on the screen. So again, we'll get to that in a second. And then, you know, just quickly looking at our update scene here, you know, besides the stuff that's already in here, such as the camera speed and the, you know, the camera movement and rotations, we do also update the position for our spotlight every frame. So it's moving along the z-axis, just kind of moving back and forth along the z-axis. Then looking at our draw scene, we basically have to get we establish an empty vector to hold the current position of our camera. Once we get that, then we're going to use that. We're going to use that specifically. This is specifically for lighting purposes. Then after that, this is the part where we set our shaders to context. So we're starting with our color light shader. We set it to context here. We send the camera matrices. We get the view and projection matrices. And then again, since the spotlight is being updated every single frame, we update its position here. And then finally, we send the spotlight parameters. So if we go in here, we have a we have a structure for our directional light, point light, and spotlight. That's all established here. And then yeah, once we have all the information set for the shader, then we just simply go ahead, we go through all of the objects that we want to render, and we just render those. So again, like I was talking about before, if we're having various instances of an object, but you know, we want to keep the same instance of the object, but we want to change something like its color or its world position, we can do that here in the draw scene and just re-render the object. So, you know, in the case of the checkers, if I pull this back up, so if I pull this back up here, so, you know, we start with our red checkers. So we set the color of our graphics object 3, we set it to red, and then we set the first position here, we render it, then we set the next position, render, next position, render, next position, render, so on and so on. And then, you know, similar for the white checkers, we just simply switch the color over to beige, and then we just render all those locations as well, set those locations as well. And it's pretty similar for all the other objects that we have in here as well. So, you know, before we render the object, if we're duplicating it, we either set its color if we want to change the color, you know, set its position and its scale, its rotation, and then just render that object. So again, our colored objects are the checkers, the chairs, and the table. And then once those are done, then we switch over to our shader texture object. We set that to context, get the camera matrices, set the exact same spotlight parameters for the textures as well. And then we send those light parameters, and then we render, very similarly, we render our dice, our pool balls, checkerboard, our carpet floor, and then the room skybox. And then if we do go ahead and just pop into one of these render functions, so kind of depending on which one we're doing. So in the case of a color light graphic object, we simply we send to the shader, we send the world matrix, we send the world information and the material. So, in this case for the color, we go ahead and send the current color of the object, because that color is sent, once it's sent over to the our HLSL to the shader itself, it's gonna take that color and the lights are going to reflect that color on the object itself. And then we simply go ahead and also render the specific model. So if we pop into that, we're just sending in the vertex buffer, the index buffer, getting that all set here as well. And besides that, I think we're pretty much all set. And then I think just one other thing, of course, we do also, since we're declaring all these objects, we have the destructor. So I've ran this a couple times here, but just scrolling through here, yeah, there should be no memory leaks. All of that, everything is all managed here. So shaders, models, textures, and graphics object, all those new things that we declare for memory, we make sure to delete those. But besides that, I think that should pretty much be it.